Hello everyone, welcome to Learn with Reza, and today I am back with another video related to Surds. So this is another request of one of my subscribers, and this is actually based on even the national syllabus, Sri Lankan syllabus, or as you can take for the GCSE syllabus, the CBSE syllabus, right? So everything is common here. So I think this will be helpful for you to learn about the simplification, especially how to multiply surd values, how to divide surd values, how to add and subtract surd values. So first of all, before we begin with the lesson, let's give an introduction. What is this surd means? Surd, or as we can give this a different names like radical, or as we can say the square root. So we can use any of these names. So any number that is under a surd, it has a value. So it can be even a whole perfect square number, right? Which basically gives a whole number, or else it can be a non-perfect square number which gives some decimal answers. It can be a fractional surd, right? Or else it can be in this format as well. Okay, it can be any decimal values inside the surd. So surd under any number, right? So we are going to learn different kinds of ones and how to simplify surds. Especially my attention is on the perfect squares and non-perfect square whole numbers. So let's start with the lesson. So first I am going to take a surd. Let's tell an entire surd. Why do I call this an entire surd? This is a whole number under a surd. So this entire surd I'm going to convert into a surd. So what is this entire surd and surd mean? Here in surd we have a number outside and a number inside. So entire surd we are going to convert to surd. Now how do we do this? First of all, this number 45, we have to divide it by the prime numbers. Possibly I can from 3. I'm getting here 15. So again by 3, I'm getting 5. And again by 5, I'm getting 1. So that means I can write down 45, the surd. I can write it in the square roots 3 into 3 into 5. Right? Now, when you observe very carefully, you can see 3 into 3 means that is square root 9 and square root 5. So, this square root 9 or the surd 9 gives a whole number because this is a perfect square. You can take 3 out, and this root 5 you can multiply with it. Now, you can see, just like as I said you, there are two numbers. So, this entire surd 45 is equal to the surd 3 root 5. So that's how you convert any entire surd into a surd value, right? Right, so let's see another example. Let's take another entire surd to convert into a surd. So if I take, let's tell 80, radical 80. So I'm going to divide 80 by the prime numbers. First by 2, again by 2, again by 2, again by 2. Now 5 and 1. So I can write this 1, 2, 3, 4. 2 into 2 into 2 into 2 into 5. And I can take this one as 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. So this is radical 16 and radical 5. So radical 16 means square root 4 and this is 4 root 5. So basically square root 80 is equal to the surd 4 root 5. So this is how we can convert the entire surds into surds. So now let's go into the addition of surds. So this is also another important part, right? So I'm going to take an example where my surd values are going to be equal. My surd values are going to be same, root 5, root 5. So when the surd values are same and the outside number is not same, we can just add these two. You get 9 root 5, 9 root 5. At the same time, if you have different surd values, for example, 3 root 3 and 8 root 2, here we can't simplify anything further. We cannot simplify this. The reason the surds are different, right? The next thing, I'll take the subtraction. Let's take subtraction. Right. 4 root 63 minus 5 root 7 minus 8 root 28. Now, in this case, you can see 3 sets of numbers with different surds inside. So, what we're going to do here? The thing is, if you just notice very well, 63 and 28 are the multiples of 7. So we can just convert them. So I'm going to take first of all 4 root 63 separately, and I'm going to write 63 in terms of 7. 63 in terms of 7 means, you know that if you know the multiplication table, 9 into 7 is 63. But if you just go on simplifying, you will notice that root 9 is a perfect square. So you can take the square root of 9, that is 3, and root 7 inside. So what you get, children? 4 into 3, 12, root 7. That's the final. And when I come to this one, you don't want to do any changes. The reason, I'm just happy because my root 7 is the same now. So my work here is to convert this 28 also, this surd into an entire surd if possibly if can. So 8 root 28. I'm going to write 28 in terms of 7, that is 4 times 7. In the similar way that we did the previous one, 4 is a square number, so I can take the square root of 4, 2 and root 7. What do you get here? 16 root 7. Now everyone is having that root 7. Now I can write the same thing again. So let me take this up. Right? 4 root 63 I can write down as 12 root 7. Right? And 5 root 7 I can write as it is. 8 root 28 I can write as 16 root 7. Now don't you see something? All the surds are same. Now what should I do? 12 minus 5 minus 16 root 7. Okay. Now we have to subtract. 12 minus 5. You are getting 8. 7. 7 minus 16 is a negative number. Minus 9 root 7. So this is the final surd answer. So this is how we do addition and subtraction related to surds. So if you remember, I taught you how to make entire surd into surd. I told you. So I'll just tell you how to do surds into entire surds also. Surds into entire surds. That's all. That one also, it's a part of the lesson. So if I take a surd, let me think of a surd like 6 root 5. I'm going to convert this into an entire surd. It's very easy. The thing is, the first number you have to multiply it by itself. And the surd number also you should multiply. Now take the whole surd. What do you get here? 36 into 5. 36 into 5, what is it? That is square root 180. So this is the entire surd of the surd 6 root 5. Clear? Okay. Now let's move into the multiplication of surds. I'll take two surd values. 5 root 3 into 4 root 2. I took two different surd values. This is very easy. Take the first whole numbers 5 into 4 and take the surd values root 3 into root 2 as a whole. 5 into 4 is 20 and 3 into 2 is 6. So you get 20 root 6. 20 root 6 is the simplification of these two surds. Now what did I say? Addition. We learnt about how to add two similar surd values. You should just add the whole number part. You can revise and see again. Then if two different surds are there, you can't simplify anymore. Subtraction, I told you how to do that. When the surd values are whole numbers, you can simplify them until you get into the same surd value. That will be easy for you to simplify. Then multiplication also done. So what's remaining now? We have, that is division. How to do divisions related to surds. Right. Have a look on this example. I'll take 3 root 20 divide by 2 root, let's tell 5. So I can write this as 3 root 20 upon 2 root 5. Okay. Listen very carefully. Now 3 root 20, I told you this is a surd. Right? That's a surd. And this is 20. I can still write 20 as 4 times 5. And here 2 root 5. So didn't you notice this 4 is a perfect square? I can take out 3 into 2. Square root of 4 is 2 and square root of 5 is standing alone. Now you can cancel root 5 and root 5. You get 2 and 2. So what's the final answer? It's 3. So this is division of surds. So in surds, you have to know few things. What is a surd? That is the radical sign. Then you have to know what are entire surds, how to convert entire surds into surds, how to convert surds into entire surds. So those two topics are over. Then addition of surds, subtraction of surds, multiplication of surds, and division of surds. But there is one more topic remaining. That is called as rationalizing the surds. How do you rationalize the denominator of a surd? Right, listen, what is this rationalizing? For example, if I take 3 upon root 2, in the starting I told you, initially I said you that there are surds which come in the denominator as well. So how do we rationalize? Rationalize means you remove the surd in the denominator. You remove the surd in the denominator. So that process is rationalizing. How do you do it? It's very easy. You have to just multiply the denominator and the numerator by the surd given. What do you get, children? If you multiply any root value, same root value, for example, root 3 into root 3, root 4 into root 4, what do you get? That number you get. Without the square root. Without the square root, you get that number. So here also, root 2 into root 2 is 2. And here you get 3 root 2. 3 root 2. So what's the final answer? Rationalized 3 upon root 2 into 3 root 2 upon 2. So hope this video was helpful for you to understand everything in a very short time without any long description about surds. Right? So then thanks for watching this video. Right? Hope you liked it. Please like, share and subscribe and help your friends too to learn this about surds. So until that, let's meet up with another video. Goodbye.